When people first hear infrastructure as code, they often assume it is just a fancy way to write down server settings. But the deeper idea is that you are encoding how your environment should come to life and stay healthy over time. The tricky part is that there are two common ways to express that intent, and each one nudges your operations toward different outcomes. Declarative infrastructure as code is about describing the end state you want, like saying the room should be 72 degrees and letting the thermostat decide how to get there. Imperative infrastructure as code is about listing the steps to take, like walking to the thermostat, setting it to 72, turning on a fan, and opening a vent in a particular order. Both can produce working systems, but they behave differently under pressure, especially when things drift, when changes are frequent, and when the environment is shared by many people and many automated processes. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A simple way to ground the difference is to separate the idea of goals from the idea of actions, because that separation influences reliability. Declarative approaches focus on goals, meaning you state what resources should exist and what their key properties should be. Then the automation engine decides the actions needed to reach that goal. Imperative approaches focus on actions, meaning you explicitly tell the system what to do in sequence, including the order and the exact operations. When you are thinking like an operator, that difference matters because most real environments are not created once and left alone. Real environments get patched, scaled, renamed, and sometimes partially broken. So you care not only about the first run, but about the second, the 10th, and the emergency run at 2 a.m. Declarative tools tend to emphasize convergence, where repeated runs keep moving the environment toward the described end state. Imperative tools tend to emphasize procedures, where the steps are correct only if the starting point matches what the procedure expects. Because operational outcomes are the focus here, it helps to picture what happens when reality and expectations don't match. In declarative thinking, drift is a first-class concept because the tool is constantly comparing what exists to what should exist. If the system finds a mismatch, it plans changes that would close that gap, and that plan can often be reviewed before it is applied. In imperative thinking, drift often becomes a hidden problem because your procedure might succeed even while leaving behind inconsistencies, or it might fail halfway because it hit an unexpected condition. That doesn't make imperative wrong, but it means you must manage the assumptions yourself, such as checking whether a resource exists before creating it, or verifying a configuration value before changing it. A beginner-friendly rule of thumb is that declarative tries to reduce the number of assumptions you must carry in your head, while imperative gives you more direct control but demands more careful guardrails. In operations, fewer assumptions usually translates into fewer surprises, especially when multiple people and systems touch the same environment. The first operational outcome to compare is consistency, because that is the foundation for dependable automation. Declarative approaches naturally encourage consistency because they treat the written definition as the source of truth and aim to make the world match it. If someone changes something manually, the next run can detect and correct it, which is great for environments that must stay aligned with policy, compliance, or standard builds. Imperative approaches can also achieve consistency, but you usually have to build that consistency by writing checks and by designing steps that are safe to run repeatedly. For instance, if your procedure assumes a network exists, but it was renamed, the procedure might create a second network instead of updating the original, producing a messy and confusing outcome. That kind of accidental duplication is not a theoretical problem because it shows up whenever people are moving fast and automation is running in parallel. Declarative systems tend to avoid that by centering the final shape of the environment, not the exact path to get there. The next operational outcome is change management, meaning how changes are proposed, reviewed, and applied over time. Declarative approaches often align well with structured change processes because you can compare the desired state definitions over time and predict what changes will occur. A small edit to a definition often leads to a visible plan of actions, which supports review and safer approvals. Imperative approaches can be very clear too, but the clarity is about the steps rather than the end result, and that can make reviews harder if the steps include conditional logic, loops, or branching behavior. In practice, people reviewing imperative automation sometimes end up asking, what happens if the environment is already in this state? Or what happens if step 4 fails? Or what happens if this variable is empty? Those are good questions, but they take time, and operationally that affects how quickly teams can confidently ship changes. If your environment is updated frequently and you rely on peer review, declarative definitions often produce a more stable and reviewable change story. Another operational outcome is recoverability, which is about how well you can get back to a safe, known good state after something goes wrong. Declarative systems often support recoverability by allowing you to reapply the same desired state and let the engine converge the environment back to what is defined. If a change partially applies, the next run usually continues from where it left off, using the comparison between actual and desired to decide what remains. Imperative systems can be recoverable too, but that depends on whether the steps were written with recovery in mind. If the procedure is fragile, a partial failure might leave behind resources that the next run doesn't handle cleanly, causing repeat failures or, worse, causing the procedure to apply in a different way than intended. Beginners often underestimate how hard it is to make a step-by-step procedure robust across partial failures, because it requires careful thinking about intermediate states. Operationally, declarative approaches often reduce the number of unique intermediate states you need to handle because the engine is always aiming at the same declared end state. Speed and efficiency are also operational outcomes, but they show up in a few different ways, and the comparison is not always obvious. Imperative automation can be very fast in narrow scenarios because you can write direct steps that do exactly what you want without extra planning overhead. Declarative automation may spend time evaluating the current state, building a plan, and determining dependencies, which can introduce delay. However, declarative automation can also become faster at scale because it can parallelize independent changes and avoid unnecessary work when the environment already matches the desired state. In imperative automation, if you do not add checks, you might rerun steps that do work every time even when nothing needs to change, which can slow you down and increase risk. The operational outcome you care about is not just raw speed, but safe speed, meaning changes happen quickly without creating churn or accidental outages. Declarative tools often support safe speed by minimizing changes to only what is needed to reach the defined end state. Control is another outcome, and this is where imperative approaches often feel more comfortable to beginners because step-by-step instruction seems straightforward. Imperative automation gives you exact sequencing, which can be valuable when order matters, such as migrating data, rotating secrets in a specific cadence, or coordinating changes between tightly coupled components. Declarative automation can still handle ordering, but it often relies on dependency relationships rather than explicit step order, and that can feel indirect. The operational trade-off is that explicit control can become explicit complexity, especially when environments differ slightly between development, testing, and production. If you hardcode a sequence that assumes everything looks the same everywhere, you can create brittle automation that works in one place and fails in another. Declarative automation encourages you to describe relationships and desired properties, which can reduce brittleness across different environments. The key is recognizing that control is not only about ordering, but also about limiting unexpected side effects, and declarative approaches often provide better guardrails against side effects by centering the target state. Observability and troubleshooting are operational outcomes that people often notice only after their automation has been running for a while. Declarative systems often produce a plan and a set of changes that are derived from differences, which can make it easier to see why something is changing. If a resource is being replaced, you can often trace that decision back to a specific difference between actual and desired. Imperative systems often provide logs of steps executed, which can be great, but the why can be buried in the code paths and conditions. When automation fails, operators need to answer a few questions quickly. What was the intended outcome? What was the starting state? What actions were taken? And what is the environment state now? Declarative approaches keep the intended outcome front and center, while imperative approaches keep the actions front and center. Neither is inherently better, but they support different troubleshooting styles, and that matters for operational teams who need repeatable incident handling, not one-off detective work. The human factor is an operational outcome too, even though it does not sound technical at first. Declarative definitions often read like a description of the environment, which can be easier for new team members to understand and reason about. When you open the code, you can see what should exist, what values should be set, and how components relate. Imperative automation reads like a procedure, which can be easier to follow for a specific task, but harder to understand as a complete picture of the environment. In operations, teams rotate, people go on vacation, and ownership shifts, so the ability to quickly understand intent is a real reliability feature. A procedural script can be perfect and still be hard to maintain if it contains many special cases and environment-specific branching. Declarative approaches can also become complex, especially when the environment has many exceptions, but they tend to push that complexity into a consistent model of desired state rather than scattered procedural logic. Operationally, that can translate into less accidental breakage during routine changes. Now let's connect these ideas to common misconceptions, because beginners often get stuck on the wrong comparison. A common misconception is that declarative means simple and imperative means complicated, but in reality, both can be simple or complicated depending on what you are trying to achieve. Another misconception is that declarative always means safer, but safety depends on how you manage changes and how you validate outcomes. Declarative systems can still make dangerous changes if the desired state is wrong, especially if small edits trigger large replacements that were not anticipated. Imperative systems can be extremely safe if they are written with careful checks, clear rollback behavior, and strong testing, but that level of care is work you must plan for. The more accurate framing is that declarative tends to provide safety through convergence and state comparison, while imperative tends to provide safety through explicit logic and guardrails you build. Operationally, you choose based on which safety mechanism best fits your environment and team maturity. Consider a practical, beginner-friendly example in your head where you are managing a fleet of systems that should all have the same baseline configuration. If you describe the baseline in a declarative way, your operational outcome is usually strong standardization, because every run tries to align each system to that baseline. If a setting drifts, the next run detects and corrects it, and you can keep your environment close to what you intended even as people make mistakes. If you implement that baseline imperatively, you might write steps like set this value, install that component, and restart this service, and it can work well, but it depends on those steps being safe to rerun and resilient to differences across systems. In a mixed environment, you might need branching logic for different versions or roles, which increases complexity. Declarative approaches often handle variation by letting you parameterize desired values while still aiming at a single model of what good looks like. That difference affects operations because standardization is not a one-time event. It is something you maintain through constant pressure from change. Finally, there is a strategic outcome that shows up over months, not days, and that is how your automation scales as the environment grows. Imperative automation often starts fast because you can solve the problem in front of you with direct steps, and that can feel satisfying and productive. Over time, though, procedural scripts can turn into a patchwork of conditionals that are hard to reason about, especially when many people contribute changes. Declarative approaches often start slower because you must learn to express intent and dependencies, and you must trust the engine to choose actions, which can feel like giving up control. Over time, however, declarative models can scale better because the environment's definition remains a coherent description of desired state, and the engine handles many of the details of reaching and maintaining it. The operational outcome here is reduced maintenance burden and fewer fragile special cases, which is a quiet but powerful advantage. When you choose between declarative and imperative, you are not only choosing a style of code, you are choosing how your future operational workload will behave under constant change. In the end, the most useful takeaway is that declarative and imperative infrastructure as code are both valid ways to automate, but they optimize for different operational outcomes. Declarative approaches tend to optimize for convergence, consistent environments, predictable change planning, and easier long-term maintenance when drift and shared ownership are realities. Imperative approaches tend to optimize for explicit control, precise sequencing, and direct procedural clarity when the path matters as much as the destination. For brand new learners, the goal is not to pick a side forever, but to recognize the trade-offs so you can choose the approach that matches the operational problem in front of you. When the environment must stay aligned with a defined standard and you expect repeated runs, declarative thinking often reduces surprises. When a task is inherently step-based, tightly ordered, or migration-heavy, imperative thinking can be the safer and more practical fit as long as you design for repeatability and failure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.